to my channel, and this is your one and only For the Love of Chemistry. Here we make chemistry simple, easy, very sweet and exciting. Alright, so today on For the Love of Chemistry, we are continuing our chemistry practicals. Because when you are done doing your titration, your qualitative analysis and the rest, of course, you need to report. And if you do not give the correct report, even though you are so wonderful, you will not get your mark. So that is why I am here to make sure that every question you are asked, you answer correctly. All right. Remember, we've done how to report our titration table, and today we are going to continue with the what? Uses of titration. The first one we did was standardization of solution, and we saw a question under that topic. The second one we did was determination of determination of molar mass, and we saw something under that. So today on the third one, we are going to do determination of mole ratio. So we have a question to do that. So our question reads 25.20 cm cube of A 0.0505 mole per dm cube solution of a mineral acid neutralized completely 25.09 cm cube of a 0.101 mole per dm cube solution of hydrogen triacylcarbonate 4 solution. Then the question says, find amount of acid used. Number B says amount of base used, and C said mole ratio of acid to hydrogen triacylcarbonate 4 in the reaction, expressing your answer as a whole number ratio of 1. So this question is quite simple. I will go right into it. Okay, so here we have that, we have we have been given the volume, and the volume, I always tell you, whenever you are taking note of what you are given, please take note of the unit, so that if there is need for you to convert from one unit to another, you will do that before you solve. Now, let's look at the question. We are given that the volume of the mineral acid is 25.20 cm cubed, and the concentration, molar concentration, is 0.0505. How do we know that it is molar concentration? Look at the unit. The unit says mole per dm cube, and we know that the unit of molar concentration is mole per dm cube. Now, the first question says, find amount of acid used, and the formula for amount is molar conc multiplied by molar volume. Molar concentration multiplied by molar volume. And we all know that molar concentration is concentration in mole per dm cube. So this is mole per dm cubed multiplied by volume in dm cube, because your molar volume is volume in dm cube. But we are not giving volume in dm cube, but we are giving volume in cm cube. So for us to convert cm cube to dm cube, we divide by 1000. So from this, we will do cm cube all over 1000, which gives us dm cube. So it is mole per dm cube multiplied by dm cube. And when, of course, DM cube will cancel DM cube. You have an answer in bold. I always do this so that you do not make mistake with your units. I want to explain this further. So let's take note of our parameters. Let's take note of our parameters. Like I said earlier, molar concentration has, this is the unit. Mole per means over dm cube, right? And our molar volume, I didn't just say volume, molar volume. Molar volume must be in what unit? dm cube. So multiply by dm cube. So if we are to sort this out, we have dm cube cancel dm cube. All we have is a mole. So what will be the unit of amount? Mole. Are you seeing how we are getting the units now? So you don't get confused. Now let's actually put in our parameters. So we have that molar conc is 0.0505 mole per dm cube, while our volume is 25.20 cm cubed. So if we are to put in everything, so we have 0.0505 multiplied by 25.20 divided by 1000, all in dm cube. You know why I'm making this known? Because it is expected. You can't just divide it and just put it here without showing what you did. You must show what you did. You must show that you converted it to dm. That's why I included the units in the solution so that it will make sense. All right. So when you multiply that out, you have. When you multiply that out, you have 0.00127 mole. So the second question says amount of base used. So it's still the same solution. It's still the same solution. Amount of base used. It's still the same way. Just fill in for the base and there you have it. So the volume of the base was 25.09 cm cube. You can, while you are listening, you can do something like this: 25.09 all over 1000 all in dm cubed. You can do this. You can decide to multiply it here, write out your answer, put the unit in dm cubed, and then carry it into your multiplication, whichever way you want. But please make sure that you show full working and put the unit. It's very important. Okay, so let's fill in. All right, our molar conc is 0.101, right? Yeah, 0.101. So when we fill in, we have 0.101 multiplied 0.101 multiplied by 25.09 all over 1000. 0.101 multiplied by 25.09 all over 1000. And when you multiply that out with your calculator, you have 0.00253 moles. So if you notice, my answer is in 3 significant figures. Of course, 0 without a number in front is not yet significant. The moment you see a number, significance begins to count. So 0.00, and we now start seeing 1. That's where significance starts. The same thing with that one over there. So we already solved question A and question B. and we got our answers. Our question C says mole ratio of acid to hydrogen triazocarbonate 4, expressing your answer as a whole number of 1. So this is mole, this is mole, and we want to find out the ratio. We want to find out the ratio. So 0.00127 moles is to, of course, we are looking for the ratio. That of the base 0.00253. So remember in your empirical and molecular formula, when you have to express a mole ratio, you have something like this. What do? You divide by the smallest number. So which of these is the smallest? So let's, this can be a little bit confusing. Let's start, let's see, 0, 0, point, 0, 0, 0, 0, 1. So this and this are in the same level. I know why I'm doing this, so that if it wants to confuse you, check it one by one. Because you might see something like this. You might see 0.01 something. I see 0.005. And because you saw 5 as the first number after the particular 0 there, you think that's the biggest one. But you didn't check the number of zeros in front. That's why I'm emphasizing this. So 0, 0, points. From this point is where you start checking, because so far there is no number here. No matter the amount of 0 you put here, it doesn't count. But from this point, now you now check 0, 0, 0, 0, 1, 2. Okay, as you can see, 1 and 2 are in the same category. So 1 is smaller than 2. So the smallest is this one. So we divide by 0.00127. 0.00127. Of course, this will give us 1 is to, what do we have here? 1.99. 1.99. I remember we are asked to express as a ratio to a whole number. So, of course, this is up to 5. So, we call it 1 and add it together. So, we have 1 is to 2, and that is your answer. Alright. So the ratio of MA to MB is equal to 1 is to 2. Please take note of, because if you put this here and put this here, and then write MA is to MB is 1 is to 2, you failed it though, because the ratio of, according to what you wrote, is wrong. I wrote B here and A here, I wrote 1 is to 2, I'm wrong, because it's not, the ratio of the base to the acid is not 1 is to 2, it's 2 is to 1. So please take note of these tiny things. Don't just write numbers anyhow. I picked the acid first because it says the mole ratio of acid to base. So I wrote the acid first before I wrote the base, so that whatever I'm getting, I can arrange my answer in that way. Thank you very much and have a beautiful day. Bye.